So I was going to try to have AI explain this to you because I don't really know how to uh, non-nerd it down. Um, it, what we're doing here is changing the way that you look at prime numbers. So this is my blog page. If you go to the link in the bottom, you'll see quantum concepts that can be wrong. And lately, I've been working on prime number theory, adapting it to more of a physics outlook. A while back ago, let's go here. A while back ago, I had done some work with binary energy dynamics. This one's actually kind of a good one. Um, uh, and it equated energy of a number when we put it into registers. And so this turned out to be kind of a natural extension of that idea, sort of. It came about in a very weird way, but basically what we wound up figuring out was that prime numbers are geometric in nature, so they have a geometry, and that's what where'd it go? Where'd it go? No. Worry about that. Close it already. So sorry. Yeah, this one. So hecking primes. This is the one that really gets into the meat about uh, you know exactly what the prime number itself is doing. So when you look at a prime number, um, what we do is we take the number line and we just bend it around. And as weird as that sounds, the let's see. Well, yeah, pretend this is the number line. We just kind of bend it around and see like this would be a prime, right? Because there's just no. Actually, no. This would be a -1 Mobius. Um, uh, but you get the idea. So you read this paper, you get down to here. Again, I'm not going to go into the math of it all. You can, it's all here if you want to kind of get into it. But you're going to get into a picture that looks like this, and when you see like the number 359, well, that's kind of telling that that's a unique look. Where 361, it doesn't look like that. And 77, which has got to be 7 and 11, that looks screwy. And 91, well, a lot of people confuse it might be prime, but it's not. I forget, it's 13 and 7 or something. 37, yeah. And then 97. You see how flat that line is, right? This is 360, right? So boom, 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 just craziness, all right, craziness. Now, this, of course, is Euler's spiral. Everybody's kind of seen this before, and when you project it out, it's got those weird concentric rings and things. This is uh, it's a spectral map that it allows you to see the bandings, and it's an FFT is a fast Fourier transformation, and it just reads the peaks. And so when you're looking at that picture, let me go back to it. You're just looking at the peaks where the energy is coming through. So when you're looking at this, it's a little different than the last one. I mean, it looks like it's the same, like kind of, but if you notice, it's not really. So again, I don't want to get into the how nutty it is, but it's all covered in this as well. So then I go into like an axiomatic proof, blah blah blah. So this talks about how to see prime numbers as this, right? Just this flat line, right? And it makes sense, right? It's there's no vectors. It's not gonna vibrate. But I did make it a little bit simpler for for like normal people. I call you muggles. Uh, so if you are interested in this, you can read this one, and it makes a little bit more sense. So I go into you know what this is doing. And I recommend that if you do go into the hacking primes one, just ask AI. Just take a section and be like, okay, what the hell is a Lagrangian? And it's basically just the least action. So bam, this is from start to finish. Where's it going? So this is the direction of force, and this here, like you wonder, well, what the hell is a Hamiltonian, right? It's just how stuff bends. That's all, kind of. It's there's a little bit more to it, and I'm not going to get into the theory on all that nonsense, but it's all on my site, and if you did, you get into that kind of stuff, it's all in here. Um, and you just kind of go to the bottom, right? Now, the latest one that I did, this one here, this takes it a little bit farther, and basically says if you spend $1 billion on a quantum computer, you may have spent too much, because basically you can do things that a quantum computer can only now do. You can do with a pencil and a piece of paper. So, and way, way faster than they could ever do. Uh, Turns out, Shor, Shor's algorithm isn't really a quantum algorithm. I know that it's going to surprise a lot of people, but it's not a quantum. It doesn't see the quantum realm the way that it's supposed to. It's a modulus thing. But anyway, you get in here, you got to read some crazy boring math, and it's all in here. I promise. It's going to start to finish. If you know how to read this nonsense, it will get you through start to finish. So I highly recommend you do it. The links are going to be, for this is, you'll go to here and you kind of just go around, but those are all the different ones. But I do want to show you. I'm going to put some more program. So this is what we were planning on doing. This is actually okay, no, I think that's the equation he was supposed to put on, but that was wrong. So we were preparing for, I was going to have AI like kind of dazzle you guys because, I'm terrible. And so we ran all the primes, and I mean, as you can see, not interesting, not remotely interesting. Um, but up here, when we first started, and yeah, yeah, that is right. No, it wasn't. Okay, they were missing something. Okay. You notice on this chart here, because we ran the same one that I just showed you in the paper. Let's go here. Right, you can see the I mean, they just go nutty when you got the divisors in there. When it's a composite, you bend that line and that's what it looks like. you know. But when it's a prime, it's just flat as a flitter. Oh, so AI's got this new memory stuff, so I can just say, hey, remember this thing we were talking about? And it's like, yeah. And it pulled up one of the original programs that we had, um, uh, yeah, that we had worked on, and it was this. So this is kind of how it's all started. So we just did a simple. Um, I mean, I know it looks crazy, but we literally just did a simple sine wave on the. Was it? I think we just laid it. No, that's not the right one. But wherever this one was, we ran the program for this, and we just literally ran a simple sine wave over the prime, and you could see look at the shape, and that's where we started. So I was like, oh, come on. And then when you ran like any other ones, they were all just all over the place, and so you could see it. But I didn't like this curve because the hell is that? So I got rid of that. I forgot exactly how I did it. But we flattened that out, and that's why you can see, you know, you know, this completely different. So there is a change, and again, I can't remember exactly what it is, but the program is whatever. It was that one that we were talking about, the hacking primes. Boom, there it is. So was that right? It just seemed wrong. I don't want to go off on a tangent because I know you guys are A short attention span. There it is. Yeah, yeah. See, he was missing the stuff underneath. Yeah, that was wrong. Anyway, so yeah, the that's it. So basically, prime numbers are geometric a phenomena. As you can see, they respond to um, pressure. Uh, so you know, put them on a geodesic and they stand straight up. Um, if you keep the line laying flat, if this is the number line, and you try to stand the primes up, they look like this. They don't make any sense. That's where the zeta function and Shor's algorithm kind of comes in. So that's when you get to after primes. Where's that? When you get to this one, I kind of combine Shor and uh, was it Shor and in the zeta function, the Riemann zeta function. I combine those two, and we're able to like resolve like like instantly. It's kind of a joke, but it doesn't really. It's the other way of factoring is so much better, but this still factors well. But there's still some that it doesn't factor. Whereas like this other way, it's instant. It's great. So um, you know this way works. This way is taken. Um, what do I say? This way is taken Shor's algorithm and the Riemann zeta function, and actually we add a little bit of the Mobius. If you're, I forget where that's at. We add the Mobius function in there too somewhere. But yeah, a bunch of squiggles. If you're into squiggles, I'm telling you, they're all here. But just if you have a question about it, just take this nonsense, copy it in here, right? Just copy it and go right to even well, Copilot's kind of an idiot, but um, you know, what is this nonsense? And it'll tell you. Sounds like Sounds like I'm dense. Oh. So yeah, it doesn't know anything. So don't really go to Copilot, but ChatGPT, it knows its stuff, and you can kind of get all this stuff and go through it. Anyway, I think that's going to wrap it up. I hope it wasn't too boring or chaotic, and thank you.